So if you have an outcome which is nominal, diabetes versus non-diabetes, you measure the proportion of people who are diabetic among the spam users and the non-spam users, or you measure the odds of being diabetic in the two groups. The usual measures of association, the usual measures of effect are ratios of those proportions or ratios of odds or difference in those proportions. So things like risk ratios, risk differences, odds ratios are the common way we measure outcomes which are binary, nominal in scale. If the outcome was ordinal, you could collapse it into a binary scale. You can measure the proportion of people who are in stage 4 of your stage of change scale, or the proportion who says their quality of life is excellent or very good. And you can do everything we did before, measuring proportions and taking ratios and differences. Or now you could calculate medians, the median quality of life in one group and the median quality of life in the other group. Take the ratios and differences of medians. And finally, if you have a continuous scale like body mass index, you can do everything we did before. You could classify people as obese versus non-obese and measure the proportion of obese people on the spam users, the non-spam users, and calculate risk ratios. Or you could calculate in each of the spam users and non-spam users the median and calculate differences of ratios or medians. Calculate the difference or ratios of those averages. So those are the various things we epidemiologists do to measure associations between risk factors and outcomes. We measure our outcome in the best way we think we should measure it. We measure it in one group, the exposed group, the spam users, the other group, the non-exposed users, the non-spam users, and then we take their ratios and take their differences. So to give you some examples, if you have a binary outcome, disease, non-disease, this is the way you might display your data. The rows correspond to your different groups. The exposed group, the spam users in the top row, the non-spam users in the bottom row. The columns, whether they develop a disease or an outcome. Diabetes is people in the first column, non-diabetes in the second column. So you might have N1 exposed users, 500 spam users. 8 of them develop diabetes. So the risk of developing diabetes, the estimated risk would be A divided by N1. That's the cumulative incidence of diabetes among the spam users. Among the non-spam users, you have a different group of 500 non-spam users. That's N0. C of them develop diabetes during this follow-up period. So C divided by N0 is the estimated risk of developing diabetes in the non-spam users. So to give you another example, here's the 4th paper I want you to read for next week. It looks at the level of co-payment in a person's insurance plan and whether those persons tended to comply with their medication. So these were people who were giving antihypertensive medication. And using their medical claims data, the investigators were able to measure whether people complied or didn't comply with their prescriptions for medication use. And you can read about how they measured compliance when you read the paper. But among the 58,000 people who had a $5 copayment, 39,000 of them complied with their medication. That means 67% of those people complied. Among the 60,000 who had a higher copayment, 33,000 complied, getting only 55%. So 67 and 55% are the cumulative incidence of compliance, the risk of compliance among the $5 copay group and the greater than $20 copay group. To measure the association between copayment and compliance, we could take the ratio or difference of these numbers. So we could calculate, if we want, a risk ratio dividing the 67 by the 55. We could turn the 67 into an odds of compliance by dividing 67 by 33. We could turn the 57 risk into an odds by dividing 55 by 45. We could get an odds ratio, the odds of compliance among the $5 copayment group compared to the greater than $20 copayment group. Or if we want, we could take the difference in risks. These are just different measures of association you can calculate from this particular table. The same thing can be done if you have incidence rates. And I think I'm going to skip over the slides to talk about odds ratio for a minute. We're running a little bit close on time, and I want to leave at least a couple minutes for questions. If you had rate data, person time among spam users and person time among non-spam users, and looked at the incidence of diabetes among those, we could calculate incidence rates in the two groups. We could calculate the incidence rates ratios. And that's what was done again in this large study I'm asking you to read next week. These are the incidence rates of developing diabetes in one group of people who received what is known as a placebo. 7.8 per 100 person years was the incidence rate for those who received a drug named metformin. And 4.8 was the incidence rate for those who received a lifestyle intervention group. You could divide these incidents one by another. For example, you could compare the lifestyle intervention group with an incidence rate of 4.8 to the placebo group with an incidence rate of 11. Dividing 4.8 by 11 would give you the incidence rate ratio, which is approximately what they have in this column called reduction in incidence. These are incidence rate ratios, approximately because they did an adjusted analysis here, something else we'll be talking about in the future weeks. So finally, the last thing I want to talk about in measures of association, just to give you a hint of what we might be doing towards the middle of this session. Regression coefficients are often used as measures of association or measures of effect. Here's a diagram I took from a basic introductory book by Kenneth Rothman, looking at groups of people defined by how much smoking they had versus mortality rates. These are people who are suffering from laryngeal cancer. This first box compares to the people who are non-smokers. The height of this box on this horizontal axis, on this vertical axis, is the mortality rate for that group of people. The next box is approximately those who smoke about a half a pack a day. The next box I'm pointing to are those who smoke about a pack a day. This is about two pack a day smokers, and finally the top box is a 3 pack a day smoker. What Dr. Rothman drew here was a straight line, which pretty much connects these 5 dots, saying there's a linear relationship between the amount of smoking you have and your mortality rate. Now, last question to think about that I'm going to ask you to think about is think back to your junior high school days when you first found out the equation of a straight line. And try to remember what that y-axis and the horizontal axis we call the x-axis. What's the relationship between y and x that's described by a straight